All right, so moving right along, the next gas law I want to talk about is the ideal gas law. Now, what we've seen so far, all the gas laws we've seen is where there has not been a change, at least the Boyles, Charleses, and Boyles, Charleses, and Gay-Lussac's, there's not been a change in the amount of gas. The ideal gas law is when you may have a different amount, okay? So please understand there's no use of 22.4 liters per mole in this situation. We are going to see the mole, but that's only at STP, at standard temperature and pressure. So if we don't have STP and you hear me ask for moles, you must use the ideal gas law. Here's the formula. PV equals nRT. And obviously all those units or all these variables, P is pressure, V is volume, N is the number of moles. Oops, we don't really, let me move this way down here. N is the number of moles, T is the temperature, and R is the ideal gas law constant. So obviously all of these, pressure, volume, moles, temperature, and then this is a constant, the ideal gas law constant. All right, so that doesn't change. And the ideal gas law constant, before I actually show you what it is, let me just show you what the units should be. If I rewrote this equation, pressure times volume equals moles times R times T, then the formula for R would be PV over NT. So if we think of pressure in atmospheres, if we think of volume in liters, if we think of moles, of course, in moles, and temperature in Kelvin, then we're going to see that our units for the ideal gas law constant is this: atmospheres, liters per mole Kelvin. And that's what we have here. All right? Now, the ideal gas law constant is 0.0821. It's a constant. You need to know it. 0.0821 atmosphere liters per mole Kelvin. I certainly may give it to you on quizzes or worksheets or whatever I might do in my class, but in terms of using the ideal gas law, that's what it is. Now, there are other ideal gas laws. I don't want to misspeak, and it's not just always this one. You can use, there are ideal gas laws for when you have different pressures or different units of pressure or different volumes. You can have pressure in pascals or kilopascals. You can have volume in meters cubed, okay? I don't even want to mention it. If you want to know what they are, go ahead, type in ideal gas law and what the values are. You'll find them. There are some different ones. I want you to be aware of this one and only 0.0821 atmosphere liters per mole Kelvin, okay? Very simply, I want to go ahead and, these are simple to use. If I were to solve one of these problems, let's say I gave you solve for the volume when there is 100 grams of O2 with a pressure of 1.5 atmospheres and a temperature of 25 degrees Celsius. Okay? So notice that I've given you an amount. When I give it an amount, then we're not thinking about the combined. Also notice that there's no changes in V's or P's or T's. How to know whether to use the ideal versus Boyles, Charleses, Gay-Lussac's, or the combined? Well, if there's no changes, if there isn't two V's given, if there isn't two P's given, if there's just one and we have an amount, then we're going to most likely be using our ideal gas law. Okay? Now I'm solving for volume. What's nice about the ideal gas law is that they're all in the numerator. There's no denominators in order to cross multiply to get them out of there. So if I want to solve for V, to do that, I would just simply divide both sides by P. So V is nRT over P. There's my simple formula. Notice I'm now going to plug them in. Let me go ahead and grab a different color. N is the number of moles. Okay, actually let me give myself a little bit of room. N is the number of moles. I don't have that yet. I have grams of O2. So, of course we know how. Grams, moles, X line. Put my labels in. Grams on the bottom because that's what I'm given. Moles on top because that's what I'm solving for. 1 mole, 32 grams. because of course oxygen is 16 grams, 16 off the periodic table. We have 2 of them. So that gives you 3.13 moles. So I'm going to go ahead and plug that in over here. That's my moles, 3.13 moles. My constant is 0.0821 atmosphere liters per mole Kelvin. And my temperature, again, cannot use Celsius. You must use Kelvin. Always use Kelvin. In this unit where we're always doing gas laws, you must use Kelvin. So add the 273 to that, you get 298 K. So 298 K over my pressure, 1.5 atmospheres. Go ahead and multiply those 3, divide by 1.5, you get 50.97 liters. Notice that my units are liters because moles canceled. In the ideal gas law constant, it's in the denominator, so it cancels. Kelvin cancels. And now because this atmosphere is in the numerator, now this in the denominator, we get liters for a unit. So 50.97 liters would be our answer in this example. All right, there's your ideal gas law. You could solve for any of those 4 different variables. I say 4 because the R is a constant.